Chapter 19, Communities and Ecosystems. So a community, and we've talked about this earlier, includes all populations representing multiple species in the same region. Now these are all living populations of organisms. An ecosystem is the biotic or living community plus the abiotic or non-living environment. Remember, the abiotic is all of the rocks, gravel, anything that's not alive. And basically, within these ecosystems, there are unique habitats, which is why physical locations where members of populations live will look a little different. And habitat loss is one of the biggest reasons that the number of animals is dying. We're getting an increasing extinction rate just because there's no place to let these animals go that's safe. Within a habitat, if you take a habitat, which would be a range, let's say a salamander that's terrestrial, it only goes to the water to breed. Well, it needs a certain level of moisture, okay, and it's got to have a certain level of humidity, and it has to have a temperature range. These are the niche within the habitat. So if we go up to the Pacific Northwest, where a species of salamander lives, you're not going to find those salamanders spread evenly throughout the habitat. You're going to find little clusters where the niche within the habitat is just right for the animal to reproduce and survive. Now, variations in light, temperature, and moisture create a wide variety of different ecosystems and communities of organisms. And here is the difference between winter and summer. Understand, here's the sun, and the Earth orbits the sun. And it orbits the sun once every year. So when it's our summer, if you'll notice, the top half is tilted towards the sun. In our summer, it's the shortest distance, so our average temperature during the day goes up. As it continues to orbit, there's the fall. And by the time it gets over here, it's the winter because it's tilted away from the sun. Then it starts moving through the spring. Or I'm sorry, this would be summer, autumn, winter, spring, summer again. So because it's tilted, it basically is how close we're tilted to the sun. Okay? And this rotates constantly. Now, that's why in the southern hemisphere, they have opposite seasons. When it's our summer, it's their winter because they're tilted away from the sun. And when it's our winter, it's their summer because they're over here, they're tilted towards the sun. Weather versus climate. Weather is just a condition of the atmosphere at a particular place over a short period of time. Climate refers to the weather pattern of a place over a long period, long enough to yield meaningful averages. Meteorology studies weather while climatology studies climate. So if I'm standing in a place on the earth and it's 78 degrees with 40% humidity and somebody predicts what it's going to be like, that's weather. When I take the average temperature of every place around the world that's measuring temperatures during the daytime, say at noon, and getting an average. Now, the number of places where we're constantly getting temperatures increases. Every year, we are getting more and more data measurement. And so as we get more and more data points, the averages become more and more accurate. The more data you have, the more accurate your predictions can become, and the more closely you can monitor them. So if I take the average of 10,000 places that are gathering temperature data at noon, that's climate. And then that's for one day. If I do that for every day for a year, I get an average temperature in that, basically, of the Earth for the whole year. So if I take the 100,000 places that are getting temperature data every year that we have access to, and we put them in a giant computer program that averages them all out second by second, or let's say we take measurements every minute, whatever, and we gather that data, we will get an average temperature for the year. All right? Now, climate can have small amounts of changes can lead to huge results. Okay? Understanding that water is like the oceans. Water is constantly evaporating and it's circulating. It as water evaporates, it moves up in the atmosphere. Eventually, it starts getting colder up there, and it will condense and then rain down as it cools. So that moisture gets blown around. The higher it goes, it rains out and the moisture leaves the atmosphere. We're constantly cycling water. Now, those temperatures rising from the surface basically cause wind currents. And those wind currents blow water and moisture and humidity around in very specific patterns. If the patterns get disrupted, that can lead to negative consequences. So in the water, we heat water on the surface, and there are multiple layers in the ocean, and that's called the thermocline. So in the ocean, if you heat the first 12 inches of water, that's circulating on top. And then the next layer never gets to the top because it's colder, and colder water is heavier. So winter when it tilts away, summer when it tilts towards. And that's because of the way that basically the equator is the hottest point on the planet, because at any point in time, it is always the closest to the sun. So here is a thermal map showing heat differences between the equator, running through here, and the poles. And part of that is the heat energy that's coming from the sun. Some of it will bounce off at the poles, whereas it's very superheated here at the equator. And then we have air circulation. Why some areas are moist and others are dry. So as we heat air, it rises. And as it rises, it cools. Once it cools enough, the moisture leaves the air and falls back to Earth. Now, we've also got the rotation of the Earth that's moving the water. And these cause water currents. And as the water heats up, we get these little water currents. Okay? Water evaporating near the equator rises, forms cloud that release rain. It's just that simple. After it releases its rain, it's very dry air. It moves away from the equator. Dry air descends around 30 degrees latitude, absorbing moisture from the land. Most deserts are near this latitude because the air that's dry descends and takes all the water out. At about 60 degrees latitude, the air mass is warmed and absorbed enough moisture from the land to rise and cause precipitation in the form of rain or snow. Cold, dry air descends at the poles. So we're constantly shuffling air around, and it is also affected by the rotation of the Earth. So the heating and cooling of the air currents causes air to circulate higher and then lower. As it comes down, it tends to condense and rain, and then as it heats and rises, it absorbs water. And then we have warm water currents that start here. The water gets warm here, and it circulates. We have this Gulf Coast stream, and these are like rivers or currents underwater. And all along our eastern seaboard, we've got this warm water coming up from the equator. But we've also got cold water circulating south from the poles. Now, this equator water. If it cools, then you end up with ice ages. Okay, this warm water brings with it warm air, and it keeps North America from being covered in multiple layers of ice. When these currents get disrupted, then problems can occur, obviously. Notice along the east coast, we've got all this warm water, but on the west coast, we have cool water. Okay, if you've ever been to Los Angeles and went to the beach, you would recognize that. So you can see water is constantly circulating away from the equator, and then as it moves towards the poles, it cools down and it comes back up, and then it gets warm again. So we've got these constant movements of water that have huge effects on the climates of the land masses. Rain shadow deserts. Here are the Rocky Mountains. If you go to California where they raise vineyards, have grapes and things like that, there's a lot of rain. You need a lot of rain to raise things like grapes and vineyards and agriculture, etc. But then, and that's because this cold air is coming along, and it has to the currents get moved up, and as they go higher and higher up the Rocky Mountain range, they get cooler, and all the water leaves the cold air. And then by the time it gets to the top of the mountains, almost all the moisture and humidity has come out of the air. And so then you get a warmer air, it drops down, and there isn't enough rain. And so you get this huge desert area in the western United States. And that stretches all the way up from the north in Utah and Idaho, things like that, Montana, all throughout Nevada, Arizona, New Mexico, etc. And this is called a rain shadow desert. Now, biomes. Biomes are basically ecosystems with distinct communities of life. So there are rainforests, tropical rainforests. There are temperate rainforests. Tropical rainforests would be like something in Central and South America. The temperate rainforest in the Pacific Northwest. There's a lot of rain up in Seattle and Oregon, a lot of it. As you move closer to the poles, you'll get taiga, eventually tundra. You have desert, tropical savannas. These are warm grasslands. Temperate grasslands and deserts. We have the temperate deciduous forest. Most of the United States is a temperate deciduous forest. Originally, when the first people landed from Europe, the eastern coast was a forest almost up to the beach. And it was solid forest through the majority of at least up to the Mississippi, probably a little beyond. Then you went into the Great Plains, huge areas of prairie, and we have cut down almost all of the temperate forest in the United States. The majority of it's gone. Okay. Temperature and moisture are the main factors that determine the dominant plants in each location. So plants have ranges they can live in. They have to have a certain amount of moisture and a certain temperature range. And if they don't have that, they don't do as well. Polar ice, extremely cold, dry, and windy. The primary producers down there are little plankton-sized plants called phytoplankton, little microscopic plants. And cold water holds a lot of oxygen, so there's a lot of fish and animals that can live down there. And it's where some of our best fishing grounds are up here in the north and down in the south, and we've outfished a lot of them. Here's the North Pole. Now, remember, the North Pole, there's no land up there past Greenland. And then there's some of the Canadian Arctic. But the actual North Pole is just a sheet of ice that covers the entire area. These are some of the animals you would find: the polar bears, walrus, there's a killer whale, narwhals. Narwhals were taken by Vikings, the Northmen, and sold into Europe as unicorn horns. There's beluga whales, the white whales. At the South Pole, we see penguins, a lot of Arctic or Antarctic birds. Now, the South Pole is a landmass. They have ice fish down there, fascinating creature. They have antifreeze in the blood because the waters are super cool. Colossal squid are eaten by sperm whales down there. The tundra is a little south of the poles, and it's a landmass, and it's cold and dry, small plants, ground remains frozen the year round. Animals have thick fur. Some of the stuff you can find up in the tundra, you can find muskox, lemmings, wolves, snowy owls, Arctic hares, things like that. Here's some other ones. Polar bears are also found in there. We're now, because polar bears are running out of ice in the North Pole, are spending more time on land and hybridizing with grizzly bears. And polar bears are in danger. In the North Pole, as the ice cap shrinks, there are ports that used to be frozen 6 months out of the year that are now open year round. And even in the North Pole region, if you go up far enough, you can actually, the Northwest Passage does now occur. You can actually ship through the north up there because of shrinking polar ice caps. And polar bears are dying because they spend a lot of time out on the open water, what used to be the ice, and they can swim, but the ice floes they're living on are getting farther and farther apart, and they'll actually drown trying to get to the next floating ice shelf. The taiga, it's a little below the tundra, and if you look at the tundra, it tends to be primarily just a big grassland. Okay, and only in the warmest months, maybe an inch or two of the surface will warm up enough, and it'll grow a bunch of grasses and lichens and things like that, very small plants. And it's a very rapid season for them to grow and then breed, reproduce, and then they go dormant again for the majority of the year. The tundra holds huge amounts of carbon dioxide because it's in a frozen state beneath the permafrost. Permafrost is the part of the land that is frozen 365 days a year. The problem with it is the permafrost is retreating. So more and more of the topsoil and stuff is thawing out. And as it does, it builds up carbon dioxide and even methane, which is normally frozen down there. In Russia, up in Siberia, they found these huge craters. And they did some research, and what they found was that all this frozen methane, as the permafrost is going deeper and deeper and more of it is thawing out in the summers, the methane builds up and some kind of little spark occurs, like maybe lightning, and it explodes and forms this huge hole and crater up there. Interesting stuff. Some of the stuff here you would find in the taiga is, snowshoe hares. These guys are brown in the summer and white in the winter, and that's basically a temperature effect on the pigment producing cells for the hair. Here's a little ermine. Lynx, bald eagles live up there. There's reindeer, tigers, wolves. These are Siberian tigers. Now, the temperate rainforest. Now we're getting down further. Okay. And, I should say here, the most common trees in the taiga are the evergreens. All right. The evergreens are able to survive better in inhospitable climates, which is where they're relegated now to. Now we're getting out of the gymnosperms and we're starting in this temperate rainforest. We'll see some, but we will also see a lot of angiosperms, flowering plants. Here's some of the temperate rainforest. Now these are animals. Some of them are from Australia. There's temperate rainforest down in Australia, kangaroos. This quoll is like a cat. Now these are elk. Temperate deciduous forest, warm summers, cool winters. And here's the United States. Right? Most of the United States used to be a deciduous forest. But, you know, the deciduous forest, you can see patches of it all across the world on the north and down at the south. All right, some animals you'd find in various temperate forests across the planet. Pandas and lesser or red pandas you'd find in the China deciduous temperate forests. There's a ferret. That's a black-footed ferret, I think. Here's a copperhead, hedgehogs, black bears. Now the temperate grasslands. These that require fire every year. Okay, this habitat, in most cases, like forests also, temporary fires that occur every year, especially here in the grasslands, kept them grasslands. There would be little evergreens, gymnosperms like ash juniper and things like that grow up. They're easy to burn. They burn really hot. And so fires would occur every year, sometimes 2 or 3 times a year. And it would burn off, it puts minerals back in the soil, and it burns off all the seedlings of these ash junipers, etc. And it keeps all the brush clear. Now, we have embarked upon, anti-fire programs to inhibit fires. And all that happens, if you can keep fires from occurring for 5 years, the amount of underbrush will increase to the point that when it burns, instead of just rapidly moving through the area and not really harming anything, it sticks around, burns hotter, and causes more damage. So controlled burns are one way of trying to keep various habitats clear of brush. And we've seen these huge fires now all over the country. And the drier and hotter the climate, the more likely that fires start. And we have suppressed fires for so many years that the amount of underbrush is enormous. You can't even hack your way through it. And so all that stuff burns. There are certain trees in the western United States that have to be singed at least once a year for them to ovulate and produce viable nuts and to breed. What has come into conflict with that is the fact that people want to live in places where fires should whip through a couple times a year. And so we have to try to prevent forest fires in those areas, but we're not clearing out the brush. So, if you're going to live in a canyon in California, and you're going to keep it from burning off periodically, you're going to have to clear out the brush some other way, which is probably going to be expensive. Here's some grasslands you'll find. There's a little fox, prairie dogs, a black-footed ferret, various hawks. Here's a giant rodent called an agouti, emus, pronghorn. There's still small pronghorn wild herds in the western U.S. Unfortunately, they're being outcompeted by the introduced animal known as horses. And a lot of people love to have those wild horses run around, but understand those horses don't belong there. Horses are not native to the United States, and they compete with bison and pronghorn, and they also destroy habitat. And the Bureau of Land Management is constantly trying to reduce the number of horses, keep their population in check, trying to catch them up, sterilizing them, gelding the males. And you can get a free horse if you want one from the Bureau of Land Management. They round up horses, and anybody that wants some can come get as many as they want. And you can break them and tame them and make them a riding horse if you want, but not very many people want to do that. They just want to leave them there because they like the idea of horses running around there. They think it's beautiful, but it is actually detrimental to the native wildlife and detrimental to the ecosystem. Any invasive species, whether it be Burmese python in the Florida Everglades or a horse in the American Southwest, is generally bad for the environment. Mediterranean shrubland. This is a unique biome that just circles the Mediterranean Sea. And its biome, basically hot, dry summers, cool and moist winters. Plants resistant to fire and drought thrive. It's a very productive area. A lot of nutrients are generated every year. And this is some of the places where the early civilizations formed because they had easy resources. There's a little Greek tortoise, certain little geckos, the mouflon, jackals instead of coyotes in the old world. The desert. The desert is not dead. It is full of life if you know where to look for it. There are plants that can survive. Saguaro cacti. Now these are, these are fascinating, and they live a huge amount of time, but they're very, very slow going. And people think it's fun to go destroy them. And most places they are protected, and they grow. And fascinating plants. You can buy seeds and grow them, but if you're 19 and you plant a seed in a pot of a saguaro cactus, by the time you're 70 years old, it might be a couple feet tall. I mean, they're slow growing. A lot of interesting organisms that live all over the world. Here's uromastyx from Africa that thrive in areas that get to 110, 120 degrees. Camels, roadrunners, American Southwest, you can find those. Fascinating little guys, little coyotes and jackals. Here's a little horned lizard that's Mollichordus from Australia. These little guys are related to elephants. Okay, and they secrete mucus here and run up and down cliffs because these rock hyraxes is what they're called, and they can run up and down because it forms suction, so they literally walk up walls. Here's the collared peccary. This is the normal wild pig. Don't confuse it with the wild hogs from Europe that have been released and are a problem in a lot of parts of the country. In most places where wild hogs exist, the season is open year-round. You can go shoot as many as you want, anytime you want. Here's a caracal, a smaller cat, but large ears. What you'll find in deserts, you'll find large ears to dissipate heat, and they tend to have skinnier legs, so blood can circulate through there and give off heat. Here's a little pancake tortoise. These guys have a kind of a flexible shell, and they crawl in rocks and up cliffs and wedge themselves into tight spots so predators can't get them. Here's a jerboa. This is an old world rodent, but here in the United States we have kangaroo rats. Tropical savanna. There's brindled wildebeest. The big African savannas where lions exist, and just tremendous numbers of various antelope and bovids. Now, bovids like this brindled gnu is more like a cow than an antelope. Zebras, cheetah. There's the Nile croc, mandrills, the boomslang. Here's a hyena. Find all of those there. Tropical rainforest, warm and wet, high species, produces huge amounts of oxygen and absorbs huge amounts of CO2. But the countries where it's found are so desperately poor that they're constantly burning down sections of the forest so they can raise cattle. things like that on it to feed their people. Some of the interiors, gorillas, you can find those in Africa. The sifaka, that's in Madagascar. Here's another African guenyon. It's Debrazis guenyon. They have the little beards, the goatees, I guess. There's the wild man of the Bornean forests. Both of these guys were legends up until the 1800s, when Europeans heard about them for hundreds of years and thought they were like wild men of the forest, and then they finally got them. The okapi, this species wasn't discovered until the 20th century. It was a legend. It's related to giraffes. The sifaka is considered to be sacred and a bad omen in Madagascar. It carries the spirit of the dead because it has this very eerie cry. These are critically endangered. A lot of these species are critically endangered. Hornbills, chameleons, rainbow boas. Here's a hornbill. I talked about that in another chapter. They basically, the males and the females, the female lays her eggs in here and raises the babies in this cavity to protect it from predators, and the male feeds her through a little slit. And then when it's time for the babies to fledge, they break open the hole and let them out. The wattled bellbird, these were discovered but lost and then found again in the 1970s. There's a gaboon viper. This is a hyacinth macaw, critically endangered. The Malayan tapir, also endangered. Most of these species are endangered. And then we have a lot of biomes that are aquatic. Okay? Lakes and ponds. True lakes are different than what you normally think of a lake. Most of the things you think of a lake is a reservoir because it's artificial, it's man-made. True lakes, like crater lakes, things like that, have water in them and maybe are fed by a river, but they're not man-made. Okay? You have lots of different types. You have deep, slow-moving rivers. You have fast-moving rivers. You have small rivers, large rivers, ponds. You have whitewater. There are certain animals that live in these whitewater stretches of rivers. That's the only place you find them. Rivers change from headwaters to the mouth, fast-moving, clear areas, different producers. Open ocean. Estuaries. Estuaries have unique fish in that they have, because they're constantly being flooded with fresh water from the rivers and salt water from the ocean. And these estuarian habitats areas are called brackish because they're not completely saltwater. So there are fish that are very tolerant of fresh and salt water that can live in there. The open ocean is, especially in the warmer climates, is almost devoid of nutrients and devoid of life. The intertidal zones, these are areas that are submerged part of the day and turn into little pools during part of the day. You have coral reefs. Coral reefs are really suffering a lot of damage, and they are a very important part of the ecosystem. They're the hatchery for a lot of nutrients that go to the rest of the ocean. So water moves continuously between sea and land, and it gets there through several ways. It primarily gets into the land through precipitation, and aquifers are big areas underground that hold water and filter it, and we pump it up. Species interactions in communities. There's several types. Competition. Competition basically harms both participants. They're competing for the same resources, the same niches, habitats, etc. Mutualism will benefit both. Commensalism will harm one but doesn't affect the other. Parasitism harms one and hurts one and helps one. Herbivory, well, it helps the herbivores, but it hurts the plants. Predation helps the predators, but hurts the game animals. Competition occurs when two or more species try to obtain the same limited resource. Here are storks in Africa fighting with vultures in Africa over a carcass. Two species can't coexist indefinitely in the same niche. and it's called the competitive exclusion principle. And one is going to be better or more successful than the other. Okay. Now in this one, these are two types of barnacle species. Okay. And when they're competing, this species can survive out of the water part of the time. This species can't. It has to be submerged all the time. So this niche, if this guy outcompetes this guy underwater, but it can't survive out of the water for extended periods of time, what you'll see is a partitioning, a splitting, and the species makeup will change. Okay. Resource partitioning. Birds are fascinating in that they might all use the same resource, but they use them at different levels within the trees. Okay, they are restricted to certain sections in the trees. Symbiotic relationships, mutualism, commensalism, and parasitism. Mutualistic relationship improves the fitness of both partners. The ants on this acacia plant eat the nectar that the acacia provides while protecting the acacia from anything eating it. If something tries to eat that plant, these big red ants will attack them. Commensalism. Some of these air plants, mosses, things like that, they benefit from increased sun exposure without harming or hurt or helping the tree. They just live up here in the top. Parasitism. One species benefits at the expense of another, so you don't want parasites. Herbivores consume plants. Predators eat prey animals. Plants and prey have adaptations that defend against being eaten. They have camouflage, like this mantid. They can mimic something that's more dangerous, and so things will be confused and won't attack it, because normally the animal they're mimicking would be very painful, have a painful bite or sting. Warning coloration: yellows, reds, deep blues, and blacks usually indicate some form of toxin or something in the skin that make they taste bad, or else they're very, very aggressive. Coevolution. These nectar tubes on this orchid are serviced by this very specialized moth that eats the nectar for food and then aids in pollinating this orchid at night. Keystone species. These are species that are absolutely necessary in an ecosystem. They keep everything in balance. If they disappear, everything falls apart. Now, these are sea otters, and they eat sea urchins. And they have to limit the number of sea urchins, because if they don't, the sea urchins will wipe out all the kelp, which is a macroalgae. Okay. Wolves are keystone species. We've seen this since we've reintroduced wolves into Yellowstone. Putting new wolves in Yellowstone has increased species diversity, changed the habitats, caused a trophic cascade, stabilize the river. I have a really good documentary in my YouTube channel on the wolves of Yellowstone. Species richness. The more different species you have, the richer the community. The fewer species you have, the more vulnerable the community. What do I mean by that? Well, if you have 99% of the plants are just one species, if a disaster happens, like a disease, it wipes out all the plant life in that area. If you've got 100 species and it's only 5% of the plant life, it's going to be spread out. It's not going to have as bad of an effect on the vegetation. It won't wipe everything out. You'll lose some, but some will survive. The more species you have, the healthier the community. Succession is the gradual change in a community's species composition. And how do they change? Well, biodiversity refers to species richness. The greater the species diversity, the more sustainable all life forms are. Healthy ecosystems can better withstand and recover from any kind of disaster. Now, if you clear cut a section of mature forest, okay, just down to the bare rock, let's say you go in and you clear cut every tree, okay, to where there's, and then basically this is how lumber companies do it. And then they use about 30% of the dead trees as lumber, and the rest they just burn or discard. And so the first thing that'll colonize that area are little lichens and mosses. Then you'll start seeing some weeds and herbs. Eventually grasses will overtake it. Shrubs will start growing. Then you'll see some of the pines, hickories, immature oak trees. Eventually you'll get a mature forest again. Now in this region, the underbrush is thick and the damage from fire is far worse. And this, when you have a mature community, you can walk through these trees pretty easily because they block the sunlight and all that underbrush can't get enough light, and so those noxious plants down there don't survive. The problem is when you clear cut, it can take hundreds of years to get back to a mature community. Right? Pioneer species would be the mosses, the lichens, the little herbs. And soil starts getting reformed because of decomposing pioneer species. These herbs and weeds break things down and help increase the amount of soil. As soil continues to form and get deeper, you'll see a succession of a more mature community. There are a lot of species that will live in these communities, but they can't survive in these other communities. So when you clear cut old forest, it can have devastating consequences on a lot of seriously endangered species. Secondary succession occurs when a community is disturbed but not destroyed, like fires. Okay? Very few communities will reach their climax condition nowadays because of artificial interferences in the ecosystem. Ecosystems require constant energy input, which we get from the sun. And then we have trophic levels. Trophic levels describes an organism's position in the food chain. Things like plants are the primary producers. Then you have some herbivores that are consumers. And then you'll have a secondary consumer that will eat the herbivores, and tertiary that will eat both the herbivores and the secondary consumers. And we're limited because 100% of the energy of the sun in the producers takes 10% of that energy and turns it into chemical energy, biomass. The other 90% is given off as heat. This guy, of the 100% of the nutrients he gets from eating this plant, only 10% is turned into biomass. And so we're limited to 3 or 4 trophic levels is about all that can be sustained in nature. Biomagnification. Chemicals are fat soluble, don't readily degrade, and they biomagnify. So basically, you don't have a whole lot in the algae and some of these producers, but these guys live off these algae and producers, and they live longer. And the chemicals in these build up in the primary consumers. So the level of these chemicals are much higher at this layer than they are at this layer per organism. And then the secondary consumers eat the primary consumers and more, all the way up to like tertiary consumers. We almost lost almost every species of bird in the United States because of heavy DDT use. DDT never breaks down. It's an artificial chemical and molecule. There's nothing that can break it down. It even killed people. It builds up in fat cells, and people who got very overweight would have huge amounts of DDT in their fat cells, and then when they tried to lose weight, the DDT, which is a poison, would cause them to die if they lost weight too fast. Cycles. Every chemical, every bit of mass in the world cycles. Okay? And they all have these different cycles. Water is constantly moving. It's maybe in the ocean, and then it evaporates and goes into the air and becomes humidity, and then it rains in the land and becomes fresh water. and then it gets put into a plant and we eat the plant, and that water molecule gets into our bodies, and then when we urinate or defecate, the water leaves it. So there's this constant movement of chemicals. Here's your water cycle. Okay. And so it's constantly moving, but we don't make new water, we just keep recycling the old water. The carbon cycle. Every kind of living organism takes carbon. It's one of the major molecules in all of our bodies. And then when we die, the carbon in our body, all the other organic material will break down and leave things like oil or coal, fossil fuels. Okay. And then there's matter in the soil. There's carbon dioxide and methane will form, sediments. So there's a constant movement of carbon through all of these different phases. Now we can release carbon into the atmosphere through fires, through breathing. Just the act of breathing, we basically breathe out CO2. Automobiles release truly huge amounts of carbon dioxide. It's the main inorganic storage reservoir for carbon, CO2. Photosynthesis takes CO2 out of the air, but cellular respiration, what we do as humans, basically releases it back into the air. And so we've got CO2 dissolved in the oceans. Now, the more CO2 in the oceans, the more acidic the oceans become. And so if you have 10 million metric tons of CO2 in the atmosphere, you'll have 10 million, they'll equilibrate into the oceans. But if we have 100 million, 100 million. So the more the amount of CO2 in the atmosphere will form an equilibrium state with the stuff in the water, but the more that gets into the water, the more acidic it becomes, which relates to pH, and that can cause disastrous consequences. If the water gets too acidic, certain species can't take that and they die. Right? All chemicals basically cycle. Nitrogen, phosphorus, goes between abiotic and biotic sources. The more we have buried, okay, this carbon doesn't affect anything unless we pump it out and use it and release it as a gas. So the planet has to have a balance of these chemicals, and depending on where the majority of carbon is going to determine how it's going to affect the ecosystem. That wraps up this chapter.